Hello everyone. Today we are gonna look into projectile motion. So projectile motion is basically a two-dimensional motion. In this video we'll also try to learn how we can apply Newton's equations of motion in two dimension. So these are the Newton's equations of motion which we have derived from one dimension. A link for the same is given below. So consider that you are in a field and you have thrown a ball at a velocity v from this point, and it went like this and it ends up somewhere here. So such kind of motion is called projectile motion at an angle theta, of course. So in order to analyze such motion, we have to understand that if a ball is moving from this point to this to this to max this again here to here, there are two kinds of forces acting on this ball. There is one force which is, or one velocity which is moving the ball in the x-axis direction, another which is moving the ball in the y-axis direction, and at top of this velocity vanishes, and then this from here onwards the velocity in y-axis direction reverses. However, the velocity in x-axis direction remains like this, and at this point both of them vanishes. So we need to learn that how we can convert this velocity into its subsequent axes. So if this is the velocity v at an angle theta, the component of this velocity in x-axis direction is Vx, and in y-axis direction is Vy. We can also write Vy here also as its vector. So in this right angle triangle, if I write sine theta, then it will be V of y upon V, because sine theta is perpendicular upon hypotenuse. On the other hand, if I write cos theta, it will be V of x upon V, that is base upon hypotenuse. Now from here we can say that V of x is V cos theta, and V in y direction is V sine theta. Now let's apply it to the projectile. We've thrown the projectile like this, it gone up and came down here. So if this velocity is v, this angle is theta, the initial velocity is in y direction is v sine theta, in x direction is v cos theta. There is an acceleration acting downwards. So we know that when the projectile was moving ahead, this vertical velocity is reducing up to a point where it can no longer take the projectile in y-axis direction. At this point, the velocity in y-axis direction is 0. However, the velocity in x-axis direction remains the same. The reason it becomes 0 is because gravity was acting against this velocity. However, in x-axis direction there is no acceleration, so it is going in a constant velocity. That is also Newton's first law of motion. So if we want to find out what is this height, we will apply Newton's equation of motion in one dimension only, in the y dimension only, considering this as a velocity, v sine theta. So we'll apply v square minus u square is equal to 2as, the third equation. Final velocity we know in y-axis direction, these are all in y, acceleration also in y. In y-axis direction is 0, minus initial velocity is v square sine square theta is equals to minus 2gh. Why minus? Because gravity is in opposite direction. So h will be equal to v square sine square theta upon 2g. So that is the maximum height which a projectile will achieve in its projected in this manner. Now we know the initial velocity v sine theta in y-axis direction. We know the acceleration, so we can also find, we know the final velocity also, so we can also find time using Newton's first equation, that is v is equals to u plus at. The final velocity, these are all in y-axis direction. The final velocity is 0. Initial velocity is v sine theta minus g times t. So time taken to reach max height is v sine theta by g. So for half of the distance, the time taken is t, that is v sine theta by g. So the total time will be 2 times of t h max, that is 2v sine theta by g. Now if we apply the distance equation, the second equation of Newton in x-axis direction, that is s of x, to find the total range, that what is the maximum distance it will travel. So s of x will be equals to u of x times t plus half at square. Now we know that in x-axis direction there is no acceleration. So if we neglect the air drag or any other force acting on it other than any obvious acceleration, then as per Newton's first law, the velocity will remain constant and at every point of time in this, on this curve. So we can write range is equals to v cos theta times t, and from here if we put the value of t here, we will get v cos theta multiplied by 2v sine theta upon g, which we can write as r is equals to v square. Now 2 sine theta cos theta will be sine 2 theta upon g. So that is the range of the projectile, that is the maximum distance. From here we can also see that sine will become maximum, that is 1, attain the maximum value of 1 at 90 degrees C, and in order for 2 theta to become 90, theta should be 45 degrees C. So at 45 degree we will get max range. Now let us try to find out what is the equation of this equation of the path of this motion. If this is the ground and you have sent a projectile from here, it goes like this and ends up here. Initial velocity is v, angle is theta in y-axis direction, and in x-axis direction their subsequent components is v sine theta, and here it is v cos theta. And so this is y-axis and this is x-axis. Let us consider a point x comma y here. That means this distance is x and this distance is y. So if I write down the equation of distance for x-axis, it will be s of x is equals to u of x times t plus half a of x t square. So s of x is nothing but x is equals to v cos theta times t, and a of x, as I have already explained to you, in x-axis there is no acceleration, only in y-axis downward acceleration is there. So t will be equals to x upon v cos theta. S of y in y-axis direction is u of y times t plus half a t square. So s of y is nothing but y is equals to u of y is v sine theta, and if we substitute the value of t from here to this equation, we will get x upon v cos theta minus g by 2, and the value of t will be x square upon v square cos square theta. So the v and v will get cancelled, and we'll get y is equals to x time tan theta as sin theta by cos theta as tan theta minus g over 2 v square cos square theta x square. So this is the relation between the x and the y of a projectile system, or the distance and the height of a projectile system. Using this equation, you can find out that for any value of x, what is the value of y. Now this is a quadratic equation, which also means that for two values of x, you will get the same y, and that is because the same height will be here and here at both the points. If we further analyze it, this will be y. This can also be written as y is equals to bx minus ax square, and this equation is the equation of inverse parabola. That's why in any gravitational field, if you throw any object at an angle theta, it is gonna go in a parabolic manner, in an inverse parabolic manner. In any cricket match, in any football match, in any baseball match, if a tank fires a projectile, everything will go in a parabolic manner. Now let's try to find out, let's zoom this region and try to find out what is the instantaneous velocity at this point. So this is the curvature, the parabolic curvature. Let us say this is the point xy. At this tangent, the velocity is v. So in order to find out the velocity, we'll again divide it into x and y component. This will become v of x. As I already told, v of x will not change, and it will become v cos theta. And this is let us say at this point the velocity in y direction is vy1. So in this is v1. So in x-axis direction, the velocity will be vx, and in y-axis direction, the velocity will be vy1, which can be reduced using this equation, the third equation, that is vy1 square minus uy square, that is the initial velocity in y direction, is equals to 2 minus g a, that is acceleration, which is minus g, times h s, or s is in this direction is y only, so 2y. So from here vy1 is minus 2gy plus, when this will go this side, it will become v square sine square theta under root. So that is how you can find out the individual component at any given point x, y, and the resultant velocity, instantaneous resultant velocity. This is instantaneous velocity will be under root of vx square plus vy square, and angle at that point will be theta. This angle tan theta would be v of y1 upon v of x, and therefore implies that theta will be tan inverse of vy1 by vx. So these are the formulas for instantaneous velocity and theta, the angle at any given point. Now we have found out maximum height, the total time of travel, the range, the equation of the motion. Also we have found out the instantaneous velocity and the angle theta. Now let's consider that if you are in a battlefield and there is a mountain here, and there is some enemy at this point which is h height above you, and you are in your battle tank here, and if you have launched a projectile at an angle theta, you have to launch a projectile at an angle theta, then what should be the velocity v so that it goes and hit this uh, target here. You can also take this condition as you're a football player and there is a player standing there, and by what velocity you should send the projectile so that the projectile goes over this height. So it is again very simple. We can resolve this into this velocity into two components. In x-axis we know it is v cos theta, and y-axis we know it is v sine theta. So, and this distance is d. This distance is d. So from analysis in x-axis we can find out that time taken for going from this point to this point will be distance upon v cos theta, that is distance upon velocity. And if we want to find out what is the height here, we can put Newton's second equation, that is h will be equals to initial velocity in y-axis time t plus half a t square. Of course there is gravity again acting in the downward direction, so this will become v sine theta, and the value of t we can put from this t, that is d over v cos theta minus g by 2, and t will be d square upon v square cos square theta. So this v and v will get cancelled, this h will be here. We can, in order to find this velocity, we can write g d square upon 2 v square cos square theta is equals to sine by cos will become d tan theta minus h. So v will become g d square 2 cos square theta, and this entire term will come down, that is d tan theta minus h whole under root. So you need not remember this equation or even any of these equations. Why I'm doing this is that how you can apply Newton simple equations in one dimension and into two-dimensional problem. Now from here you can see that for any given theta, value of theta, there is a certain velocity. So if you change the angle theta, there will be a different velocity, and of course this problem can have different solutions. Like you can hit the ball, hit the target like this, you can choose to hit the target like this or almost like this, but for every different angle, these angles, you will get a different velocity which you can derive from this equation. And that is how any such kind of problems can be resolved. So this simple projectile motion derivation is useful in many applications. I hope this was helpful. Thanks. Don't forget to like, subscribe and share the video. Please leave your feedback and questions in the comment section below. Press the bell icon to get instant update from the channel Hands on Physics.